Good morning. So, good morning. Today we'll work with we started with syntax directed translations, syntax directed translations. Right? Am I audible? And we have two types of syntax directed translations. One are synthesized, one are synthesized translations. Second is inherited translations. So in case of synthesized translation, we have seen that the left-hand side of the production rule is dependent on the right-hand side on the variables is dependent on the variables of the production rule on the right-hand side. So this second is basically the attribute of a variable, right? Of a variable or a non-terminal. For example, here it is E2, right? Okay. So this is the meaning attribute, or we can say it as the meaning. This is the meaning of this, right? This is the meaning of this. For example, if I want to write 2 plus 3, so this is my first is that E1, this is E2, this is E3, this is plus, right? And here it will lead to this E2 leads to digit, right? This also leads to digit, and this digit is basically returned by a lexical analyzer because this is basically a regular expression. We write the digit as a regular expression as we know 0 or 1 or 2 or 3 and so on up to 9. So, so this particular digit is returned by the regular expression. So we can write it as our lexical analyzer, sorry. So we can write a digit dot lex val is equals to 2, for example. We write here it as the meaning of this particular is digit dot lex val is equals to 3. And then we create the dependencies here. It gives me e2 dot val is equals to 2. So this is the meaning of this one. Okay, it consists of this particular value, right? Because this particular lex value, these are the dependencies, right? E2 will be dependent upon this one value. E3 will be dependent upon this particular value. So this is the dependencies that we will show when we are building the semantic analysis. So we know that in case of semantic analysis, input is parse tree generated from syntax analysis page, and output is complete parse tree with attributes, and their values, with attributes and corresponding dependencies, right? Okay. So from here we will get here E3 dot val is equals to 3, and it gives me E1 dot val is equals to, because this is the addition procedure or production rule is related with the plus. So this gives me equals to 5. So in this way we write the complete, that you know. Now this is a synthesized translation. This is a synthesized translation. Why? This is because the left hand side of the production rule will be dependent upon the value of the right hand side of the production rule, right? And if your production is something like this, A tends to BC and B dot val is equals to 2 multiplied, for example, A dot val. So the value of this particular children, right? Okay, this is a children. If I create the syntax tree for this, so this is created something like this, A, B, and C. So these are the children, siblings. Okay, this is the parent. Now the value of this particular b is dependent upon this particular parent, okay? Because b is equals to 2 multiplied by a dot y. Okay, so we did all this particular stuff in our previous lectures. Now we will do the implementation, right? What will you do? Implementation of syntax directed implementation of syntax directed translations using stack, right? Implementation of syntax directed translations using stack. Okay, so to implement syntax directed translation, we have to use stack, which consists of a pair of arrays, right? So one is state, it consists of a pair of arrays, and second is value. This is the stack, and it consists of the pair of arrays. One is state, and second is value, right? So, for example, so what is the state array, right? Each state entry shows a pointer to a parsing table, and each value represents the value associated with the corresponding state symbol. So state array consists of all the variables or identifiers appeared in the context-free grammar, and value array consists of the values of each variable, right? So for example, we can see here, right? Okay, instead of going through these two definitions, we can directly go to an example that how we uh, initialize the stack, right? Okay, so this is basically our stack, right? So there are two different types of stacks. One is stack before reduction, because if I'm performing the bottom-up parsing, right, then bottom-up parser will perform the corresponding translation when my BC will get reduced to A. When my BC will get reduced to A in case of bottom-up parsing. In case of bottom-up parsing, when my BC will get reduced to A, then that particular translation will occur. Then that particular translation will occur. Okay, right. So again, there are the two different stacks. One is stack before reduction, before reduction. Second is stack after reduction, stack before reduction and stack after reduction. Again, it consists of a state of and value, right? So before reduction, if we have a production rule like A tends to BC, so what is in the stack? Okay, so I will write here. From here, I will start. So first of all, first entry is B. So it consists of B with its corresponding value B dot val. Okay. Next in the stack entry will be C, and it consists of the corresponding value C dot val. So this is top of the stack for the moment, and this becomes, if this is top, then this is top minus one. This indexes are quite useful now, okay, when we are defining the meaning of that, okay, and if we are defining the meaning of this, when we are defining the meaning of this. So to implement a sentence directed translation, we have to make use of stack, one thing, right? First thing is this. Second is this. This stack consists of a pair of arrays, right? And what is that pair? One is state and second is value. State consists of corresponding variables or non-terminals, and value consists of their meaning, right? That is attributes. That is attributes, right? Okay, so translation will occur in case of bottom-up parsing when we reduce BC to A, right, with this corresponding handle, right, with this corresponding handle, then translation will occur. It will reduce your BC to A in case of bottom-up parsing. So initially we have a stack before reduction. Now this is a stack before reduction. Now after applying bottom-up parser, we get a we get a stack. We get a stack after reduction. So this is my production rule. A tends to BC. So BC will directly get replaced by this particular non-terminal on the left hand side, and we are only left with A here and its corresponding value A dot well. So this is on the top of the stack in case of this one. So this is the way we are working with our implementation of syntax directed translations. In case of we have a stack, it consists of a pair of arrays. One is state, having two fields. One is state and value. Okay, is it clear? Is it fine to all? Please reply to the chat. Okay, is it clear? So that we can work ahead. So, okay. So further, we start with an example. Okay. Example says that consider the following grammar of for having an application as desk calculator, and the production rules of this particular grammar G are, the production rules are S tends to E dollar. Dollar signifies the right hand marker, end of the string. E tends to E plus E. E tends to E star E. E tends to E. E tends to I tends to I followed by a digit. Okay. And I tends to digit. So we have these particular production rules. Right, we have these particular production rules. And what is where you can this is the digit will basically return to lexical analysis phase. So we will write the regular expression for this, where digit is, because its meaning is this one, right? The meaning for digit is digit dot lexval. Why we are writing this lexval? Because this digit is basically returned through our lexical analysis phase. So that's why digit dot lexval is written, and it consists of some value, for example, 5, for example. Right? So where digit is equals to 0 or 1 or 2 or 3 or so on up to 9. Right. Okay, the very first, I'm not writing it here because I require some space further. Right. So this is understood to you, right? Okay. Okay. So what I'm trying to say now, my first question is here, write down syntax directed translation scheme, syntax directed translation scheme for given grammar G. Grammar G. So how do we write the syntax directed translation scheme? So for that we have to represent, always remember we have to represent in the terms of a table, and this consists of first serial number having the production, corresponding production, and associated semantic action. This is our syntax directed translation scheme. And I told you that semantic action is always written in the curly braces. Right. Okay. So my first production, I write the first of the same production as tends to E dollar. Right. So corresponding semantic, this is the final thing, right? Okay. This is the final string I will get here at the start symbol when I reduce it, or if I'm performing a top-down parsing, then when I expand it. Okay. In case of top-down parsing, I am expanding. In case of bottom-up parsing, I am reducing. Okay, remember this thing because this all thing is known to us here. We done a lot of things, right? We constructed an LL1 parser in case of top-down parsing. We constructed a SLR parser, LR0 parser, CLR parser, and LLR parser in case of our bottom-up parsing, right? These all are related with the bottom-up parsing. Our in case of bottom parsing, we have a SLR1 parser, LR0 parser, CLR parser, we call it as the LR1 parser also, as well as we have LA-LR1 parser. Okay, look ahead LR parser. So we did all these particular in our previous lectures. Okay, so now it is directly understood to you if I'm talking about expanding or reducing what I'm talking. If I'm talking about expanding, it means I'm talking about the top-down parsers. If I'm talking about reduce reduction, it means we are concerned with our bottom-up parsers. So this is, we say it as the print, right? What should I print? E dot val. Okay, this is the semantic action associated with our first production. Now, second production is E tends to, for example, E1 plus E2, right? So what is the semantic action is that E dot val is equals to E1 dot val plus E2 dot val. Okay. Third is E tends to E1 star E2. So what is my semantic action? E dot val is equals to E1 dot val star E2 dot val. Fourth action is E tends to E1. So what is my semantic action? E dot val, just have a copy of E1 dot val. Okay. Fifth action is, what is my fifth action? E tends to I. Okay, right. So this gives me E dot val is nothing but that is equals to I dot val. That means I will get copied into E dot val. In this way, we have a precedences, right? That is the curly braces. Sixth is I tends to I digit. Okay, so okay, so I'm leaving this, right? Sixth is sixth. I urge you that you will solve it. Okay, seventh I will do for you. I tends to digit. So this gives me this corresponding semantic action is I val is equals to, what should I write the corresponding semantic action for this? Is equals to digit dot lex val, or I can simply write it as lex val for our simplicity. Okay, or we can write it as this one, lex val. Now, can you write the semantic action for this? Right, I'm building a syntax directive translation scheme for the given grammar G, right, having 7 production rules. So can you write the semantic action associated with the 6th production rule, that is I tends to I followed by digit. So please write this corresponding semantic action for 6th one and share your answer through chat. Okay, share your answer through chat. Right, write it down. Right, I will wait for 2 or 3 minutes, right, for you, so that you can write the semantic action for this I tends to I dot digit. No, this is not correct. Anything else? Okay, anyone else? Any other response or to try to do it again? Okay, this is not the correct semantic rule for this. This is not the correct semantic rule for this. Rohan, try to do it again or try to think more about this. Okay, others will also try to do that. So this is a kind of a two-digit number. This is a production rule that deals with a two-digit number because I tends to digit followed by digit. Okay. So if I'm writing the production rule for this, so what I have to write? I have to write the semantic action for this, right? Okay. So semantic action tell me the meaning. So how do I create the meaning of this? So I dot val is equals to, I should something like this, plus lex val, and here I should write here 10 multiplied by, right? 10 multiplied by I1 dot val. Okay. So this is the corresponding semantic action that is associated with this particular rule number 6. Because this is a two-digit number. Okay. This is a two-digit number. Because I tends to digit, it gives me I tends to 6th production rule gives me I tends to digit followed by digit. Right, digit followed by digit. If it is a 23, so for example, then we will write 20 multiplied by that particular place value plus 3. Okay. This is the way we are working. Clear? Is it fine? Right. Okay. Sorry, I have written it wrong. Right. This is not something like this. What this is 10 multiplied by I dot val. So this is my I dot val here. Okay. Right. So this is 10 multiplied by I dot val is 2. This is something like written this one plus the next value that is 3. Then it is. This is a semantic. Is it fine to all? Is it fine to all? Please reply through chat or any doubt to you. Right. So further, note down this particular grammar, note down these particular semantic actions. Okay, note it down or take a snap of this one, right? Entire screen and try to solve these particular questions, right? Okay. We have not yet explored how to implement syntax directed translation, right? Syntax directed translation using stack. Okay. That we will discuss in next lecture. But before to that, do something, right? First, I did for you that you have to write down the syntax directed translation scheme for the given grammar. Now I'm saying you construct the complete parse tree. construct the complete parse tree, right? Construct the complete parse tree with the translations, okay? With the corresponding translations for the string, for the string 23, for example, star 5 plus 4 followed by dollar. Okay, right. Then we will, in next lecture, we will discuss the sequence of moves. We will discuss the sequence of moves made by the parser in stack. Okay, sequence of moves in stack made by the parser for the same string 23 star 5 plus 4 followed by dollar. Okay, so first of all, you will construct this string. We have discussed all this. So construct the complete parse tree with translation for the string 23 star 5 plus 4 followed by dollar. The grammar is given to you. This is your grammar. Okay, right. So, so implementation of syntax translation using stack we will discuss in next lecture because it requires one lecture, entire single lecture. So any doubt to you, right? Please take a snap of this particular whole screen, right, and try to solve it out. What I told you to do. Okay. So if you had any doubt, please share your doubt through chat or any other way. Yes, Katinder, any doubt to? Have you noted it down or? Okay, Katinder. So you will try to complete the entire parse tree. Okay, I will share the same with you in next lecture, and we will start working ahead with the implementation of syntax character translation using stack. Right? Okay. So any other doubt? Okay. Okay. Bye.